guests and AWS community members. Welcome to the flagship event, AWS Community Day Kochi 2023. We are thrilled to have you here, united by community-led learning and diverse technological experts. Experience insightful sessions and workshops led by industry leaders and community heroes at this venue. And don't miss out on the chance of participating in quizzes during the event for getting a chance to win exciting goodies to take home. Without further ado, let's dive into the heart of our event. Our first session features Ansil H. He's a lead SRE at Cisco with 10 plus years of experience in cutting edge technologies. He's someone who takes active participation in CNCG Kochi and also a strong supporter of community activities and would be taking a CNCG Kochi workshop on introduction to the CNCG world with Kubernetes. Ansil, take it away. The audience is all yours.
Hi all. Okay, so how many of you are familiar with CNCF? All are, or it's very new? New to CNCF? Okay. So how many of you know Linux? So yeah, then we can start from Linux. So the entire world is actually on running on Linux now. So you all know. So everything else is abstraction on top of Linux. So the Linux Foundation was started to coordinate all the effort from the Linux community efforts. And afterwards, what happened was many open source softwares were developed by the community, and that was started eating the world. So everything was, I think, most of the college folks will be doing open source projects, and they will have a GitHub account. The moment they join, they will create a GitHub account and they will start coding. So that was the trend, and the entire ecosystem. So earlier days, um, if you want to use any technology, then you have to write your own code. Uh, so now you don't have to. You can go to GitHub, search for it, you will get it. So someone else might have made it open source already. So that is why we say, yeah, software is eating the world. And then it was open source. So it was enterprise systems or enterprise companies who are developing the software and they are selling it to the customers. And it was not affordable to small business and even college students. And that is how even Linux started. So the Linux was developed by Linux Torvalds, and he started it as a college, a side project in his college. So they were using an operating system called Minix, and that was not open source. So he wasn't liking it, and he started his own, developing his own kernel, and that it became Linux. So that is how the open source journey of software started, and many other things happened. So if you know Apache, or Nginx, most of the web were running on Apache. Um, so that is one of the example how the open source is consuming everything. So then afterwards, cloud started, right? So cloud was providing all the easy way to install, configure, and deploy the open source software. So in a different form or in their own opinionated way. So one of the example is virtualization. So the virtualization was there in Linux for a long time. The virtualization was called KVM or Xen, and that is the technology which AWS used in there. Xen was the first hypervisor they used to run the VMs. So that is how cloud started eating the open source. So then there are a lot of cloud providers, like you have AWS, Azure, Google, Oracle. So then the customers were confused, like how can I make sure that the business I'm going to run that can that is not going to have dependency with the cloud I'm using. That is, they don't want any vendor locking. So at that time, many things were happening. So one of the thing was containerization or containers or Docker. That is, the microservice architecture was coming up. And then Kubernetes came into the picture. So that is the first project that kicked the thought of cloud native. That means if you are running Kubernetes in your cloud, then your application will run. So in any cloud provider, if you use Kubernetes, then your application can be run without any problem. So that means there is one common way the end user can consume the cloud without worrying about a vendor locking. Suppose tomorrow you want to change your application from AWS to Azure or Azure to AWS, you can do it without any much issues, I would say. So this is what industry needs. Is they don't need any confusion. So if I'm writing a software, and if I'm a business, I'm going to run an application, then I need guidance and clarity how to do it, and the quality, and a common set of tools. That means if I'm going to learn one set of tools, then that should be usable for all the other cloud providers. So what is cloud native? So cloud native means, so before we get into cloud native, so in old days we use something called three-tier architecture. You have a front end, you have a middle, and you have a back end, right? So in most of the time that will be a server and a network and a SAN storage. So it was a server rooms, and that was the old days. So it was not really easy to scale. That means tomorrow if you have 100 customers, then the server you will be using might not be useful. So that means you have to add more nodes. You have to scale your infrastructure. So then you have to make the software to be scalable. So instead of you do the hard work, so there is a set of rules were made or a set of standards were made. If you follow it, you can easily scale your infra or scale your application based on the workload, and you don't the developer don't have to worry about how to do it for their own. So that we use nowadays is container based in most places and microservice oriented. So microservice means you will not have a one big monolithic application, that it will be sliced into simple application that can scale individually. So we decouple each of these small pieces so that we can scale it. So for example, if you have one big program with multiple functions, so imagine you are moving that one function to one separate application. And you can scale that application or a function based on the input that it gets. So all these functions will be executed in CPU, right? So imagine you are getting, the function is getting called 100 times. So that means the CPU will be called 100 times, right? So if it is running on same system, then that will be shared across all the other applications or all the functions running in it. So if you get a flexibility to split that main program into simple functions, and if it can run on different machines, then you can scale it independently. So that is what we are doing with microservice architecture. You are splitting it up, you are decoupling it. That means not much dependency with other places of your application. So you can scale it based on the demand. And another one is programmable infrastructure. That is where you are going to run, that should be programmable. That means, so yeah, we'll come to that. So the cloud in cloud native means it can be any cloud. It is not just the public cloud. It can be even private or even hybrid. So private cloud means you can have your own cloud running in your data center. And hybrid cloud means the combination of public cloud and your on-prem a private cloud. So this is the definition of CNCF. So you can read through it. what exactly that means. So if you can reconnect all the things I said, it's all summarized into this one slide. So how the CNCF came in. So the familiar term we hear in CNCF world is web scale. That means I want to be the next Google or next AWS. So which technologies I can use. So CNCF is the one place you can look into, and you can look for the applications or the infra tools uh, to deploy host your application. So in CNCF there are many projects which are um, which you can see from the CNCF.io. So this landscape card will give you the graduated projects or incubated or in sandbox. So this is one screenshot I took from the graduated projects. So as you can see, some of the key items are Kubernetes, HCD, Cilium, Containerd. So we are going to see some of these and where these applications or tools will fit in CNCF or the application that you are going to develop and run. So the first one is Containerd. So Containerd is a container engine. Um, so in traditional infra, you will have one hardware, a virtual machine running on a hardware, and there is one hypervisor that is handling the VM, and then guest OS, then the libraries, then your application. So there is multiple layers in it. So imagine you have two versions of Ruby running in same system. That means you need to manage two versions of Ruby without causing any problem to the applications running in it. Tomorrow, one developer says, "Hey, I want to upgrade the Ruby runtime in one of the application." So, and I'll go ahead and upgrade it. Then the other developers or other team will say, "Hey, my application is broken. It is not running, and you should revert it back to the previous version." So then the other team will complain because they need the newer version. So there is a conflict. That means there is a dependency of the version of library or the tools we are using, right? So that means we have to decouple it. We have to find a solution to decouple that dependency. So there comes the container engine. So instead of throwing the application to the ops team, so what you can do is, as a developer, you can use container technology to combine your application and its dependencies together and create an image and then give that to the ops team. So then that image can be deployed in a container runtime system. So we'll come to that where we are going to deploy it. So Containerd is one tool that you can use to run container images. So just like a hypervisor, there will be container runtime you can run. So these are abstractions. So that in hypervisor you can create, in virtualization you can see there is a hypervisor layer. But in container world, there is no real abstraction. So it will still run as one process inside the operating system, but it will be isolated. So that isolation technology, we call it as containerization. That is, we are containing it. So I'm not going in depth anything about containers. So we'll have another session, and in that session you will get more about containers. So the next one is where you're going to run it. So you can run one instance of your application using one container, right? So based on the workload, suppose you want to run 3 or 4 or 5 instances of the same application, and then you want to load balance it. And tomorrow someone says, "Hey, I want to upgrade it." So how you're going to upgrade that 5 or 6 instances of the same application? So there comes the need of an orchestration or orchestration tool for the containers. So that is called Kubernetes. Kubernetes is the orchestration platform for containers. So you can use Containerd or Docker to run one instance of your application. That can handle that specific workload. Maybe it's only 1 or 2 users. So based on the demand, you cannot really scale it. So you had to manually go and spin up one more container. And for upgrading that image, you had to manually go and change that images on each of those instances that you're running. So that is not easy. So for that, you can use a container orchestration tool called Kubernetes. So Kubernetes have a few key components. One is called Kube API server. So Kube API server is like the brain that handles all the instructions that you provide. That means you are saying, hey, create this workload. That instruction will go to Kubernetes API server. And there is a persistent store called HCD where all the configuration will be stored. That means when you are running the application or when you are saying, hey, run this application, when the system restarts, suppose the Kubernetes system is restarting, then when it comes up, it needs to know what was the state of the application, right? That means it has to read the configuration or the information that we provided so that it can bring up the same application again. Or it can reconcile. That means suppose something happened to the application. So how it is going to make sure it is going to be up and running all the time. That means it need a state to compare with, right? So that persistent state will be stored in HCD. So the Kubernetes API server will be interacting with a component called kubelet, or you can call it as node. So you can easily translate that name to multiple VMs or multiple machines. So a kubelet is kind of an agent running on each of these VMs or servers, and Kube API server will be interacting with each of these nodes. So just like you manage, how the antivirus is being managed in your laptop. That means in one center place, someone is pushing the updates to your laptops. So likewise, this Kube API server will be interacting with all the VMs or all the machines using an agent called kubelet. So the instruction that you say, hey, create this application, that instruction will go to Kube API server. Then Kube API server will send that application creation instruction to that agent, one of the agent. That agent selection is based on the workload. That means suppose your application should not be running on the same node which is already utilized. Suppose the CPU is already high, usage is high, and you don't want to run your application there. That means it will cause slowness, right? So that means the Kubernetes needs to know the state of each of these VMs, how much resource were used, and how much is free, things like that. How to schedule it, literally. So there is a component called Kube Scheduler. So you can see at the bottom. And that is the one who's going to decide where to run it. So that is a kind of an overview of how the orchestration system works. And I know, so visualizing this is very hard. So I'll show you how all these things are done in real world, or at least a demo. So HCD is a persistent store that is used by Kubernetes. This is one of the CNCF graduated project. And HCD is, again, imagine if you have one node database, and if there is any corruption happened, or something happened to the file system, then your data is gone, right? So to avoid that, what you will do? What you will do? One is database backup. Another one is you'll create something called a sync replica. That means whatever the transaction that you commit, that will get replicated to another remote database instance. So here in HCD, we have a similar concept called replicated machine state. So it uses an algorithm called Raft. So if anyone of you are from college, then you can take this as one of your internal assignment to learn a Raft algorithm. So it will help you a lot in your interviews if you are going for a system level or a system engineering interviews. So Raft is an algorithm that will help to keep the machine state in sync or replication state in sync. That means if you write to one instance of HCD, that will get replicated to other two. And if you read from it, at least two of them should agree. Yeah, the data that you're reading is good. So in a HCD cluster, you need minimum 3 nodes to have high availability. You can run one, but you cannot run two. Why? At least 50% of, more than 50% should agree that the data is good. So in a 2-node cluster, what will happen? Only 50% vote will come, right? That is not enough. So you cannot run 2-node HCD cluster. That will not work. So you need 3, or you can say like odd numbers. So 1, 3, 5. So in Kubernetes, mostly people will be running 3. So that is where you store all your application configurations. Not application configuration, how you are going to run the application. or how many instances of the application should be running, what version of the application should be running, and on what kind of node it should be running. So all those information will be stored in HCD. So the next project is Cilium. Cilium is the container networking interface. So in Kubernetes, we run containers, right? So each of these containers, you can imagine is like a VM. So in a VM, you will have network, right? So in containers, how we are going to configure network. That also needs to communicate with the outside world, right? And other application components. So your front end might be interacting with the API. So how that interaction happens. So it has to go through network. So that network is again abstracted. It is not using the actual network that you use in your VMs. It is not. So there is an overlay or an abstracted network layer that is again handled by something called a CNI. So this is another tool in CNCF landscape. So Cilium is one of the CNI that you can use. You will hear about more about CNI, eBPF. eBPF is a technology that is used to run the network stack. So I am not going in depth. So you can keep these words in your mind. CNI, eBPF, Kubernetes, HCD. So you can connect all these dots later on. So the next one is core DNS. So as I said, you can have an application front end and there is an API server, right? So how they are going to interact? It is going to use the CNI, that is a networking layer, but how it is going to identify, hey, I have to interact with this API. So in real world, what you will do, you will create a DNS entry, then you will configure your application to point to that DNS. Or if you have a database, then you will configure the database entry, or you will configure that database URL in your application, right? Then the application will write to it. But in Kubernetes, in a distributed system, you have thousands of instances running. It is very hard to manage that naming convention. So you need something called a service discovery or automated service discovery and name resolution. So for that, there is another tool called a core DNS. So core DNS is one of the tools in CNCF landscape that helps service discovery. And the next one is Helm. So as I mentioned earlier, you are actually going to say, yeah, I have to run this application, right? You have to tell Kubernetes cluster that I have to run this application. This is my software version, and these are the other dependencies. So how you are going to create that package for your application. So when you develop a software, you can create something called an installer, right? You'll create an installer or .setup.exe. So that will have all the dependencies. So that you can install in a Windows machine. So likewise, in Kubernetes, if you want to package all your application metadata, and you can use another tool called Helm. Helm is a tool that you can use to package your application for Kubernetes. So just like you write your setup.exe, you can write Helm charts. So we'll call charts. And it can be hosted somewhere in a repository, and you can give that link to your customers. Then you can say, hey, this is where the Helm chart is hosted, and the customers can use that Helm chart to deploy it in their Kubernetes clusters. You don't have to worry about where that Kubernetes cluster is. So that is what I was saying earlier. There is no vendor dependency. So if it is on Kubernetes, your application can be deployed. So there are some tweaks and other things that you need to know, but 99% of the time, the Helm chart that you create, that will run on all the clusters if you are using Kubernetes. So that is what CNCF stands for. It is cloud native. So cloud native means made for. So let's get into the demo. So in this demo, we are going to create a VM in VirtualBox. Okay. Yeah. So it is VirtualBox. So how many of you know VirtualBox? All? So this is the best place you can try out all these things which I just mentioned. So you can create a VM, but remember a few things. You should have internet access. That is one. Second one is when you create a VM, make sure you have a NAT network. So by default, there will not be a NAT network. You can create one if it is not present. So that is what I have highlighted there. So there is one host-only network, and another one is a NAT network. So you can see that. So the NAT network will be automatically configured. So once you complete it, the next one is you are going to create a VM. So you can use Ubuntu, the latest version of Ubuntu. So I'm using Ubuntu 22 version. Hope everyone can see. It is visible, right? So yeah, you can set the CPU and memory based on your VM's configuration or your laptop's configuration. Or so here I have plenty of CPU, so I get it. And here you are going to set the disk size. Then the next key thing is we are going to configure the network. So here, remember two things. One is the first interface will be the host-only network, and the second interface will be NAT. So these are the two interfaces you need. Then yeah, we'll power it on. So that will start the Ubuntu installation. So Ubuntu installation is very straightforward. You can just do next, and it will complete the installation. Maybe I can fast forward a little bit. So yeah, it is installed. No, it is not. It is getting installed. So it is a minimal installation I'm selecting. You don't have to do the full installation. And I'm selecting LVM, that is a logical volume management, so that if you run out of space, you can expand it. So once you do it, it will start the installation. So yeah, and you can select the time zone, and you have to set the user that you're going to use, and you can set the password and all the things you can provide here. So the installation will start, and it will take some time. And let me skip to, yeah, it will say, yeah, restart now. So after the installation, you can restart it. It will come up. So once it comes up, then the next thing that we are going to do is we are going to install something called a container runtime. So remember, we discussed about container D. So container D is the container runtime that we use for running the containers. So if you are the first time using the container ecosystem first time, try Docker. Docker is another engine that you can use. It is very user friendly, and that is what I'm going to use here. So you can follow this workshop easily. So once I log in, I have to get to the, yeah, you can skip all these things. You don't have to really do anything. So yeah, you have to configure the networking piece. So by default, okay, let me get back to that screen one more time. So that is because it's an important one. So if you look at that networking section, one is connecting, one is connected. So the bottom one is connected, which is a NAT network that we selected when we created the VM first time. So that is connecting automatically to the internet. If your laptop or desktop have internet access, and your NAT network will help the VM to reach the internet. You don't have to worry about configuring any internet access or anything. The first one is your host-only network. That is your network within your laptop or your desktop. So that network, there is no DHCP configured. So either you can choose to have a DHCP running in VirtualBox that will assign an IP address automatically, or else you can configure one manually. So if you go back to the first VM creation step, there it was select to DHCP off. So if you look at it, you can see that. And if you set it, then you don't have to configure this network. It will automatically pick it up. It will pick up an IP address. But here I am configuring it manually so that you can see how it is done. So if you click on that setting, then you'll get a window like this to configure the IP address. So there I'm setting the IP address, subnet mask, that's it. So why we are doing all these things? Because our ultimate goal is to run Kubernetes, right? So now it is connected. Once the IP address is configured, you can reconnect the network and it will pick up the IP address. And then you can connect to that system using SSH, right? How many of you know familiar with SSH? All right. So it is not connected. Why? What the error message is. So pay attention to the error messages that you get. Say connection refused. That means either the service is not running or someone else is blocking it, right? So here the service is not installed. So we are going to install SSH first so that we can access it from our system instead of logging into the VM console all the time. So we'll install SSH and curl. Why curl? We need curl. Sorry. Yeah. So we need curl command to download the software we need. So we are connecting to SSH, logging into the system, and then we are going to install Docker. So you can, I will share all these steps. Yeah, we are going to enable this service so that every time when you restart the VM, the SSH will come up. It will be enabled by default, but yeah, so just to ensuring it. So the next step is we are going to install Docker. So this script, it is in Rancher. So Rancher is another open source tool for orchestrating Kubernetes. So they created this script to install Docker. So you can just copy paste that one script. It will help you to install Docker. Docker is the container runtime that we are going to use. So the installation is done. So it's as simple as that. So the next thing is the user that you are going to use from your session that need access to Docker or something called a Docker socket. For that, your user has to add it to a Docker group. That is what I just did. So you can see a user mode command. The next one is we are creating a Kubernetes cluster using a tool called HUGKOCHI. So to set up Kubernetes, there are different ways. One is the Kubernetes the hard way. That means you can configure each component manually. So remember the diagram which I have shown. There is a Kubernetes API server, there is an etcd, there is a kubelet, scheduler. So you can configure each of these components individually, or you can use a tool that will help you to deploy Kubernetes. So I'm going to use a tool called HUGKOCHI or Rancher Kubernetes Engine. So there is another tool called kubeadm that you can use. So for simplicity, I'm using HUGKOCHI. So yeah, I'm going to download it. That is what I did, and then give execution permission. So these are some of the key steps. So remember we are configuring when we are discussing about the architecture. There are kubelets or individual agents or VMs, right? So we have to say what are the IP address and which username we can use to log in and configure these VMs. So all those things will happen through SSH. So what we will do is we will configure an SSH key and we will copy that SSH key to all those VMs. Then we will tell the RKE that, hey, use this SSH user or this user to execute the command to configure Kubernetes. Because someone has to go and do it, right? So that actions will be done through SSH. So there we need something called a passwordless authentication. So the passwordless authentication happens through SSH. So those are the steps we are doing here. I think we have another 20 minutes or so remaining. So yeah, so this RK config, so when you execute this RK config, it is going to ask how many number of hosts you want to configure. So here I'm using only one, a one node Kubernetes cluster. And here it is asking what is IP address. So you will provide the IP address, and what is the SSH port, it is the default, and private key path, everything else is default. So I just provided this IP address, everything else is default. But here the username I have gave is Ansil instead of Ubuntu, because the user I have created during the Ubuntu installation is Ansil. That is my name. So you can use the same name here, because the RK has to know, it has to log into those system, right, to configure it. And it is asking whether it is a control plane host. So control plane host is, you can say, where the Kubernetes API is running or HCD is running. That is called control plane. So that one node VM will act as control plane. Then you can press Y. So here, is it a worker host? That means, is it going to act as a worker host along with a control plane? And then you will provide the network plugin type. So this is another thing we discussed about, that is called Cilium CNI. So we discussed about how the networking is handled in Kubernetes, right? So there we discussed about something called Cilium CNI. So this is the place where you provide which CNI we are going to use. But here I have selected the default canal, but we are going to change it. So we are going to use Cilium. I'm not going to use any of these. So these are the CNIs you can use, but I'm going to use Cilium. So once you provide all these settings, yeah, it is going to create a file called cluster.yaml. So you can edit that cluster.yaml file, because we have to change the CNI to none, because I want to manually install and configure the CNI. So I don't want RK to do it. So I have to do it. So in this way, you will get an idea how flexible this tool is. So you can customize. So either you can go with the stock, that means you can go with all the default options, you'll get a Kubernetes cluster. It is as easy as that. But you have the flexibility to configure it. So once you have that cluster.yaml file configured and you set the networking to none, then you can do something called RK up. So during this RK up, it is going to dial to each of the hosts that you have provided, and it is going to configure the component that you selected. So here we have only one node, right? And it is configured as control plane, HCD, and worker. So RK is going to execute SSH command to it and run the commands to configure the Kubernetes cluster. So that is what it is doing. So you can do it manually if you want. So you can spend your weekend and you can configure it manually, and you can learn how all the things are happening. Or it is very easy to use RK and do an RK config and RK up. So yeah, it is going to pull the images. So remember, we need internet access. So this is the reason we configured NAT, because it is going to pull the images needed to run Kubernetes from internet. So there is something called a Docker Hub, where all the container images are hosted. So Kubernetes components itself are packed as container images. So that is getting pulled from that registry now. So you don't have to worry about all these steps happening. So only thing that you have to worry about is here, not here, not here. No, not here. Yeah, here. Building Kubernetes cluster successfully. That is the only message you have to worry about. If you get this, you can forget about everything else. That means your cluster is up. So once that completes, then you can do an ls command to see there are two other files created. That is called a cluster.rk state and a kubeconfig cluster.yaml file. These are the two files you have to keep in handy all the time. So this RK clusters, this cluster RK state file is the one that keeps the state of your cluster itself. Tomorrow, if you are going to upgrade your cluster, then suppose something happens. So how you're going to roll it back? And if you have some certificate changes that you want to do. So there are some internal components that needs to be updated. So all those states were stored in this RK state file. So always keep the backup of this RK state file and kubeconfig cluster.yaml file when you play with it. So always keep a good copy, then modify it if you want to. Then once the cluster is up, how you are going to interact with the cluster. So you need a client, right? A CLI. So for example, if you are running a database, you need a client to connect to that database so that you can run the SQL queries. Likewise, in Kubernetes, you need a client to interact with the Kubernetes. So we use a tool called kubectl or kubectl. So we are downloading that Kubernetes kubectl now, and we are using the curl command. Remember, we installed curl command at the very beginning. So, and once you do it, the next one, I think did I skip to quick? Yeah, I did. So the next tool we need is, yeah, I think I skipped this. So how you are going to tell kubectl that which Kubernetes cluster you are going to interact with. So imagine you have 3 or 4 Kubernetes clusters. So that means you have to tell kubectl that which cluster you are connecting to, right? So you are using an environment variable called kubeconfig, and you can pass the kubeconfig file that is generated by the R key. Then kubectl will use that config file to connect to the Kubernetes cluster. So the next one I'm going to download is Helm. So remember the Helm package manager. So it is the kind of the installer we use. So for that, we are using Helm command. So we are downloading the Helm as well. So yeah, here is an example you can see. So once you do the kubectl get nodes, you will be able to see the nodes